Hi, and welcome to one of our final Honors 390 videos, the leading driver of greenhouse gas emissions and an economic review of carbon policy. Every day we hear about climate change, but we don't always talk about what's actually driving most of these emissions, or how our policies shape the solutions. In this video, we'll give an overview of climate change, break down the leading source of greenhouse gas emissions worldwide, and investigate how carbon policy really works from an economic point of view.
The Intergovernmental Panel on Climate Change, commonly referred to as the IPCC, is a global scientific assessment report that will be referenced multiple times throughout this video. The central issue regarding greenhouse gas emissions is that current atmospheric levels are the highest ever recorded in human history, and they continue to rise at an accelerating rate. According to the IPCC, scientific consensus shows human activity is the dominant driver of these emissions, accounting for the overwhelming majority of greenhouse gases being released into the atmosphere. A wide range of sectors contribute to the output of greenhouse gas emissions. The primary drivers include economic activity like agriculture, industry, resource extraction, technological systems, energy/transportation, infrastructure, and many other processes that are embedded into today's society. Importantly, the term greenhouse gas emissions refers to multiple gases that are emitted, not just carbon dioxide. While CO2 is the most discussed, other gases such as methane, nitrous oxide, and fluorinated gases also play significant roles but are often overlooked. The atmospheric blanket of greenhouse gases is thickening. The following visuals come from Our World in Data. Although methane gas and nitrous oxide are not the leading drivers of greenhouse gas emissions, the two of these graphs show their ties to agriculture. Methane is emitted primarily through livestock as it is a byproduct of their digestive processes, whereas nitrous oxide is primarily emitted from nitrogen-based fertilizers used for agriculture. The IPCC report makes it clear that greenhouse gas emissions have reached the highest levels in human history. Although growth rates have shown to slow in recent times, emissions are still increasing and temperatures will continue to rise until the world reaches a net zero emission. Reports also warn that although many countries are taking measures to reduce emissions, there is fear that they are being done too slowly in order to stay within the 1.5 degrees Celsius to 2 degrees Celsius budget. This temperature range is what scientists have estimated to be the rising threshold range, where if we exceed, we may see severe impacts. The mechanism behind greenhouse gas-driven climate change is not widely understood, so here's a visual depiction of the process from the NASA website. The first step in the process, sunlight reaches the Earth. Next, some energy is reflected back into space. Then, some is absorbed and re-radiated as heat. Finally, most of the heat is absorbed by greenhouse gases and then radiated in all directions, ultimately warming the Earth. Why do we care about greenhouse gas emissions? The primary reason why humans should be concerned about this issue is due to the fact that human activity is the dominant driver of the unprecedented rise in atmospheric greenhouse gases. Ultimately, it is up to us as humans to make a change. Over the last couple hundred years, across a number of sources, including the IPCC report as well as the NOAA Global Monitoring Laboratory, have modeled what started as a very gradual increase to rapidly increasing levels of greenhouse gas emissions. The increased greenhouse gas emissions has led to rising temperatures, creating a cascade of negative environmental impacts. In the same way that each of us has one body, there is only one Earth, and it requires the same intentional stewardship that the human body requires. Our actions shape the planet's future, and safeguarding it demands a shift in how we approach daily life and broader systems. Before the extensive environmental degradation caused by human activity, our Earth was in a much happier state. To now, one that feels the everyday consequences of human repeated reckless behavior. Ironically enough, the Earth is calling for desperate help from humans before it reaches its tipping point. Based on the high-resolution CO2 record published in Nature in 2008 by Luthi and colleagues, over the past 2 centuries, atmospheric carbon dioxide has climbed from about 280 parts per million to over 420 parts per million, a rise faster than any natural variation seen within the last 800,000 years. This visual comes from the Our World in Data CO2 emissions database, which is maintained by the researchers at the University of Oxford. Here is a visual aid that shows the progression of CO2 emissions alone over the last couple centuries. As you can see, the trend leading up to the year 1900 increased very gradually. From the year 1900 to present is when CO2 emissions began to take off. During the mid-1900s, around the time of the Third Industrial Revolution, widespread habitat destruction occurred, increased manufacturing, and the use of electronics began to boom. During this period, CO2 emissions grew tremendously. They have continued growing at a rather alarming rate, however, have shown a slight decrease in recent years. A rather sharp decline during the early period of the COVID-19 pandemic in the year 2020 is also shown. This shows a direct correlation between human activity and carbon emissions. Among the main drivers discussed earlier, all of them contribute to the greenhouse gas emissions crisis that the Earth is facing today. The leading contributor to greenhouse gas emissions globally, according to the IPCC and World Resource Institute, is electricity and heat production. This is largely due to the fact that many countries still rely on coal and natural gas to power their grids. As society advances and electrifies more and more aspects of daily life, the demand for electricity rises at a rate that is often much higher than the rate that clean energy can replace fossil fuels. This drives emissions up significantly. Although carbon does not account for all greenhouse gases, it comprises about 74% of greenhouse gas emissions. And of that 74%, 92% of CO2 emissions come from fossil fuel use. This particular model from the IPCC is a great representation of how electricity and heat is the leading driver of greenhouse gas emissions globally. This source estimates that approximately 69% of total greenhouse gas emissions comes from electricity and heat. This graph is from the World Resource Institute, which shows similar data but at a more precise breakdown. It is estimated that about 75.7% of greenhouse gas emissions come from energy. The way that this data is broken down makes it seem as if greenhouse gas emissions from electricity and heat fall at a lower percentage. However, this is just due to how the data was analyzed. The second largest contributor is transportation, coming in at 13.7%. NASA explains that the Earth is warming at an unprecedented rate, primarily due to human activity, particularly the rise in greenhouse gases since the Industrial Revolution. The planet's average surface temperature has gone up about 1 degree Celsius since the late 19th century. The oceans have absorbed the majority of the extra heat, and sea levels have risen about 20 centimeters in the last century. Widespread indicators such as shrinking ice sheets, retreating glaciers, decreasing snow cover, and increased frequency of extreme weather further reinforce the conclusion that the climate is being rapidly altered. This image was pulled from the United Nations Climate Action website and places emphasis on the biodiversity consequences of rising temperatures driven by greenhouse gas emissions. As you can see, if the temperature were to rise plus 3 degrees Celsius, 41% of mammals would lose half of their habitat.
Now let's switch gears. Let's start by looking at the real-world economic and human costs of climate change. A 2023 study published in Nature Communications by Newman and Noy found that extreme weather disasters linked to human-caused climate change are already costing the world about $143 billion every year, and 63% of those losses are tied to human mortality rather than infrastructure damage. That means the biggest cost isn't repairing buildings, it's the value of human lives lost. The study also highlights that developing countries face the greatest impact because of their inability to act on it. Another interesting fact from the IPCC is the wealthiest 10% contribute about 36 to 45% of global GHG emissions, which raises major ethical concerns about global responsibility. So when people say climate change is too expensive to act on, the truth is the cost of doing nothing is far higher. So what can we do about it? According to Van der Ploeg and colleagues, effective climate change action depends on 3 key tools. First, carbon tax. Secondly, cap and trade systems. And third, renewable energy subsidies. These policies help internalize the cost of emissions, meaning polluters finally pay for the damage they create. A carbon tax puts a price on each ton of CO2 to motivate cleaner choices. Cap and trade sets a cap on emissions and lets companies trade credits under that limit. Renewable subsidies help reduce the cost of clean energy, accelerating adoption. These policies don't just reduce emissions, they encourage innovation. Now the big question, do carbon policies actually work? Research by Kolstein and colleagues from 2024 analyzed 121 countries, and they found that increasing carbon prices by just $10 per ton results in a 1.3% emissions reduction in the short term and up to a 4.6% reduction in the long term. Meanwhile, a 2025 study of the European Union emissions trading system found that the policy led to an 8 to 12% reduction in emissions among participating firms, without even harming economic growth or employment. So the argument that climate regulation kills the economy doesn't hold up in the real-world data. Of course, nothing is simple here. Research by Aldi from 2020 highlights several challenges in implementing carbon pricing. For example, political resistance, public fear of rising energy costs, uncertainty about market reactions, and global fairness concerns, particularly between wealthy nations and developing countries. Infrastructure change also takes time, and voters are rarely patient. So what does a realistic path forward look like? The same 2024 cross-country analysis by Kolstein and colleagues show that countries with strong carbon pricing policies, paired with renewable energy expansion, energy storage investment, and nuclear power stabilization, see the greatest emissions reduction impact. Add in technology innovation like carbon capture, hydrogen fuel, and efficiency systems, and there's a clear roadmap for meaningful progress. Also, global agreements like the Paris Climate Accord help align nations towards shared reduction goals. So that the solutions exist, the question is whether we choose them in time. Now let's take a look at the final takeaways. The biggest driver of CO2 emissions is electricity and heat production, and climate change is already costing us billions and lives every year. Carbon pricing tools work, but policy resistance and equity challenges slow progress. The good news is that scalable solutions already exist, from renewables to nuclear to global cooperation. We don't need to reinvent science, we just need to act faster. Thank you.